Hi, we are Team Polyglots, and today I'll give you a quick walkthrough on our final year project, which is improving cross-lingual representations of multilingual large language models. So, what are we actually trying to solve? So, you might have noticed that large language models perform much worse for low-resource languages such as Sinhala, Tamil, and Punjabi, compared to high-resource languages such as English, Chinese, and so on. So, what we try to do is make low resource languages perform much better in different tasks when we use large language models. So we had two main objectives. So the first objective is to enhance cross-lingual performance of Sinhalese, Tamil, and Punjabi through various techniques which we explore further. And also, our second objective is that we improve Sinhala's monolingual capabilities through tokenized extension and continual pre-training. So I'll give a quick walkthrough on how we achieve the second objective. So to do that, we trained a model which we call SynLlama, and I'll walk you through on how we did that. So first of all, we did the data collection, which is like we used two well-known open data sets, which is MATLAB and CulturaX. So these are like large corpuses of various text, and we got the Sinhala split of it, and we combined those two data sets, and then we did some data cleaning and deduplication, and like we did all those data validation things and all, and then we ended up with around 304 million tokens. So using this combined corpus, we trained a new tokenizer. So what we did was we got the existing llama tokenizer, and we embedded our new tokenizer into that to create a much larger tokenizer, which is able to tokenize Sinhala much more efficiently than the llama's tokenizer. So then we use this tokenizer and the llama based model, and using the same pre-training corpus we performed continual pre-training, and then we ended up with what we call llama, which is our base model. And then in order to come up with the instruct model, we had to do some instruction fine tuning, and for that we use the Bactrian X dataset, which is a translated version of the Stanford alpaca dataset, which is usually used for instruction fine tuning. And that's how we ended up with SynLlama and SynLlama instruct. So now let me walk you through how the tokenizer works and why it's very crucial in this. So let's take this simple singular sentence of Obata Subu Dasanak. So if we tokenize this sentence using the Llama 3 8-bit tokenizer, we would end up with something like this. And this is like, as humans, we don't understand this. And even if we feed it to a model, so you can see like that fertility is 28, which is not a very good number. And also we know, like, since the model learns relationships between tokens, and here these are like somewhat of a character level relationship, so like the model actually doesn't grasp the exact meaning of the sentence, because like what it tries to learn or predict is like the relationships between these characters. But when we use our new tokenizer, which we call the SynLlama tokenizer, we can see like it has been tokenized into much efficiently with a fertility rate of 5, and also even as humans is like very comprehensive, and like even the model, we can be sure that the model understands this format much better. So this is what we use to pre-train our model, and also during inferencing and like everything we do with the SynLlama model, we use this tokenizer. So next I'll just give you a quick overview on like what we actually did to the architecture. So this is what we have, the default llama 3 8-bit architecture. So like since we had extended the tokenizer, and like the dimensions of like the embedding layer and the output layer have changed a bit, so it has become a bit larger due to the addition of the new tokens and the changing of the embeddings, but overall it's like basically the same architecture. So only the first layer and the final layer has changed, and the remaining layers are as it is. So let's see how good this was. And so we actually did lots of benchmarking, but I walk you through something which is like very easier to understand and much more like easily visualizable. So this is what we did for zero shot classification on uh, and we compare it to Llama 3 and the Llama 3 instruct, and as well as the Sin Llama and Sin Llama instruct. So here we have like by base, what we mean is like we use that model as it is, and fine tune, what we mean is we fine tune that model specifically once again for classification. And as you can see, um, across all four models the fine tune model performs much better, but also you can see that the Sin Llama and Sin Llama extract are like much better in terms of like, so especially when you fine tune it, is much better on like the one specific task. And yeah, and also we have the f1 score on the y-axis here. So like as a conclusion, what we can say is like, if there's one specific use case that we need to use a large language model for singular as in, so we can train Llama for that specific use case, and that would perform much better than the existing models such as Llama. Uh, and so this is our team, and our supervisors are Dr. Nisansa De Silva, Dr. Surangika Ranatunga, and Dr. Rishenjit Kaur. And yeah, we also have to acknowledge Dr. Rishenjit Kaur from CSIR India, and also Emojet Private Limited for the computer resources that we used for the pre-training, and as well as the other experiments as well, which was not mentioned here. And yeah, thanks a lot, and have a nice day.